When installing an underground electrical service that spans over 200 feet from the meter socket to a pedestal with a 200 amp main disconnect supplied by a utility transformer, you absolutely must include a grounding conductor alongside your feeders. This is crucial for safety and to meet the requirements outlined in the National Electrical Code (NEC). The grounding conductor serves as a low-impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as breakers or fuses in the event of a ground fault. This helps to quickly clear the fault and minimize the risk of electrical shock or fire. For a 200 amp service where the distance from the meter socket exceeds 200 feet, the NEC dictates a minimum size for the grounding conductor. According to the NEC and specifically referencing NEC Table 250.122, a 200 amp service requires a grounding electrode conductor to be at least number 4 American wire gauge, UG, copper or aluminum. This size is determined by the size of the ungrounded conductors. In this specific scenario, you're using 250 mcm aluminum XHHW cables as feeders. The installation of the grounding conductor is equally important. It must be installed within the same trench or conduit as the feeders. This ensures that the grounding conductor is exposed to the same environmental conditions as the feeders, which can help to minimize impedance and voltage drop. The grounding conductor must be connected to several key points. Firstly, it should be connected to the grounding terminal within the meter socket. This provides a direct connection to the utility's grounding system. Secondly, the grounding conductor should be connected to the pedestal mounting bracket. This ensures that the metal enclosure of the pedestal is properly grounded, minimizing the risk of electrical shock if the enclosure becomes energized due to a fault. Thirdly, and most importantly, the grounding conductor must be connected to the grounding electrode system at the building. This typically involves one or more ground rods driven into the earth, a U for ground, which is a concrete encased electrode, or other approved grounding electrodes. The connection to the grounding electrode system provides a direct path to earth, allowing fault current to dissipate safely. There are several additional considerations to keep in mind when installing the grounding conductor. Firstly, the grounding conductor should be continuous and without any splices or connections. Splices and connections can increase impedance and reduce the effectiveness of the grounding conductor. If a splice is absolutely necessary, it must be made using an approved method and properly insulated. Secondly, the grounding conductor should be protected from physical damage. This can be achieved by installing it within a conduit or by burying it deep enough to prevent it from being damaged by digging or other activities. Thirdly, it is recommended that the grounding system be tested to verify its continuity and resistance. This can be done using a ground resistance tester. A low resistance reading indicates that the grounding system is functioning properly. A high resistance reading indicates that there is a problem with the grounding system that needs to be addressed. Now let's delve into the relevant sections of the National Electrical Code (NEC) to provide a more comprehensive understanding of the requirements for grounding underground services. NEC Article 250.66 specifically addresses the size of the grounding electrode conductor. The size of the grounding electrode conductor is based on the size of the service entrance conductors. In your case, you are using 250 mcm aluminum conductors. According to NEC Table 250.66 for 250 mcm aluminum conductors, the minimum size of the grounding electrode conductor is number 4 AWG copper or aluminum. It's crucial to consult this table directly to ensure you are using the correct size grounding electrode conductor for your specific installation. NEC Table 250.122 dictates the minimum size of the equipment grounding conductors for various overcurrent protective devices. While Table 250.66 focuses on the grounding electrode conductor, which connects to the grounding electrode system, Table 250.122 addresses the equipment grounding conductor, which runs with the circuit conductors and connects to the equipment enclosures. For a 200 amp overcurrent protective device, such as the 200 amp breaker in your house panel, Table 250.122 specifies a minimum equipment grounding conductor size of number 12 AWG copper or number 10 AWG aluminum. However, it's important to note that this table applies to equipment grounding conductors within the branch circuits and feeders, not necessarily the grounding electrode conductor for the service. It's essential to differentiate between the grounding electrode conductor and the equipment grounding conductor to ensure compliance with the NEC. The grounding electrode conductor connects the service equipment to the grounding electrode system, while the equipment grounding conductor connects the non-current carrying metal parts of equipment to the grounding system. Both are essential for safety, but they serve different functions. Let's consider some potential scenarios and how the grounding requirements might apply. Imagine the underground service runs through rocky soil. In this case, it may be necessary to use multiple ground rods to achieve a low resistance connection to earth. The NEC requires a resistance to ground of 25 ohms or less. If a single ground rod does not achieve this resistance, a second ground rod must be installed at least 6 feet apart from the first. Alternatively, you could use a UFA ground, which involves encasing a length of bare copper conductor in concrete. This method can often achieve a lower resistance to ground than ground rods, especially in areas with poor soil conductivity. Another scenario might involve the presence of metallic water pipes near the building. In this case, the NEC requires that the metallic water pipe be used as a grounding electrode. However, the water pipe must be supplemented by another grounding electrode, such as a ground rod or a UFA ground. A connection to the water pipe must be made within 5 feet of its entrance to the building. Now, let's address the specific materials you are using, namely 250 mcm aluminum XHHW cables. Aluminum conductors have a higher resistance than copper conductors, so it's important to ensure that all connections are properly made and that the correct size connectors are used. Aluminum connectors must be specifically designed for use with aluminum conductors to prevent corrosion. These connectors are typically marked with the letters ALCU, indicating that they are suitable for both aluminum and copper conductors. When connecting aluminum conductors to copper conductors, it's essential to use a suitable transition connector to prevent galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. The transition connector prevents the flow of electrons between the two metals, minimizing the risk of corrosion. The XHHW insulation on your cables is a type of cross-linked polyethylene insulation that is commonly used for underground installations. XHHW insulation is resistant to moisture and heat, making it suitable for direct burial applications. However, it's still important to protect the cables from physical damage by installing them in a conduit or by burying them deep enough to prevent them from being damaged by digging. When installing the underground service, it's crucial to maintain the correct burial depth. The NEC specifies minimum burial depths for underground conductors based on the voltage and the type of installation. For a 200 amp service, the minimum burial depth is typically 24 inches. However, this may vary depending on local codes and regulations. It's always best to check with your local electrical inspector to determine the specific burial depth requirements in your area. In summary, properly grounding an underground electrical service over 200 feet requires careful attention to detail and strict adherence to the NEC. Remember to use a correct size grounding conductor, install it properly, and connect it to the appropriate grounding electrodes. By following these guidelines, you can ensure a safe and reliable electrical installation. Remember that this information is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. It's also important to check with your local building department to ensure that your installation complies with all applicable codes and regulations. Also, it is important to know that local amendments to the NEC can sometimes add additional requirements that must be followed. Therefore, knowing and following local regulations is very important.